Hello dear students, welcome to my channel. In this session we will see determination of total alkaloidal content, and I will explain the procedure by calibration curve method by which you can determine the total concentration of an alkaloid content in any given plant material. So like the video and subscribe the channel for more updates, and you will find lot many contents related with an education, especially in pharmacy field, on my channel. We will see the first principle of this alkaloidal estimation. Say in this method it has been based on the reaction of an alkaloid with bromocresol green, which forms an yellow color complex, and this yellow color complex, it is formed at a specific pH, that is 4.7. so we need to utilize an phosphate buffer for the maintaining an pH at 4.7. At that instant, this complex between bromocresol and alkaloid, it has been formed, and later on the complex which has been formed, so this complex, it has been dissolved in an organic solvent like an chloroform. So in the procedure we will have an chloroform solvent, and it has been extracted. This complex, it will be extracted using an separating funnel, and after that we need to determine an absorbance by UV spectrophotometer, and the lambda max utilized for this purpose, it is 470 nanometers. At first instant, we have to prepare a calibration curve. See, in this calibration curve, we will have a concentration, different concentration of an alkaloids, and we will measure an absorbance. So with the help of that, we will have firstly a calibration curve, or we will call as a standard curve. Once a standard curve it has been formed, we will take a plant material, and this plant material, it will be estimated, it will be extracted in the chloroform, and the procedure for it I will discuss with it, and after that we need to extrapolate it and find out the concentration whatever it was, and we need to use a dilution factor for the purpose. So first we will see the procedure for standard atropine solution, or we will also call it as a stock solution. So for that purpose, take an atropine, that is 1 milligram of an atropine you need to take, and 1 milligram of an atropine is to be dissolved in 10 ml of an distilled water. So for the purpose of an calibration curve, utilize only an distilled water for it, and after that you will get a concentration. So the concentration, what concentration ppm does it form? Like so 1 milligram, for that purpose ppm and the relation between ppm, part per million, and microgram per ml. Microgram per ml and ppm both are same, and for this purpose what we need to do, so we need to convert a milligram. So 1 milligram, it is equivalent to 1000 microgram. So 1000 microgram, so 1000 microgram we are dissolving in 10 ml distilled water. So 10 ml distilled water, so I will write here 10 ml distilled water. 1000 microgram is to be dissolved in 10 ml distilled water. So it becomes an 100 microgram per ml. 100 microgram per ml means it will be an 100 ppm solution. 100 ppm solution. So this solution that you have to prepare, and there are some more other solution like bromocresol green solution of an that is indicator, and one more, that is phosphate buffer solution. For that purpose you can refer the IP. I will not discuss the procedure for it. Now for an calibration curve we need to prepare an aliquots. So accurately measure the aliquots, that is 0.4, 0.6, 0.8, 1 and 1.2 ml. So these are 5 concentrations for calibration curve of an atropine, and transfer in a separating funnel. So don't transfer directly to an volumetric flask. We need to form an complex, and then we need to extract it. Now in separating funnel, See this standard atropine solution, that is the aliquots which we are taking. So for this, what you do, so this it is an like separating funnel. I will draw over here. So this it is an separating funnel, and in this you have to take this atropine. So I will write just A for atropine, and phosphate buffer, that is 5 ml. So it is of 4.7. So you can refer the procedure for phosphate buffer from IP. So take it 5 ml. So I will just write buffer. So that is 5 ml, and plus you have to take bromocresol green. So again you can refer the IP for this purpose, or you can refer any cognosy book for the purpose. So that is 5 ml of an BCG. So I will write here indicator. So indicator, that is 5 ml. So make a mixture of all this in a separating funnel and then shake it. So shake it well, and after that you need to take an chloroform. So it will form an yellow color complex, yellow color kind of an complex which will be formed, and so we need to extract in chloroform. So here we don't confuse that with 1, 2, 3, 4 ml, because we have to add step by step. So this it is a mixture. Add firstly 1 ml of an chloroform, then remove that chloroform in a volumetric flask, right? In a volumetric flask, remove that chloroform 1 ml. After that, again add 2 ml of chloroform in the same mixture. So 1 plus 2, again add in a volumetric flask. After that 3. So again extract with 3 ml, and after that extract in with 4 ml. So the 4 times you have to extract it. 4 times you need to extract the complex in a chloroform, and total volume it becomes 10 ml. 1, 2, 3 plus 4, it becomes 10 ml, and add to this 10 ml volumetric flask. Now further, if required, if the volume it is not exactly in 10 ml, if it is little bit less, it will be not happen that it will be more in ml, because we are taking accurately this. If it is less, you can adjust with the chloroform if required. If there is nothing requirement, then you can keep as it is. So because of a dilution of an chloroform, so there will be no impact of on an absorbance. And see, the thing over here is that, understand it, when we this standard atropine solution, and after that BCG, it forms an complex. So here it forms an complex, and this complex it is formed at an pH 4.7. We are extracting that complex in a chloroform layer, in a chloroform layer, or we can say a solvent. And that solvent, whatever the solvent we have extracted within chloroform, so we are calculating an absorbance. So there are 5 aliquots, 0.4, 0.6, 0.8, 1 and 1.2. So now we need to find out an absorbance at 417 nanometer, as we have discussed in the principle, and then we will get such kind of an calibration curve. So here it will be concentration, and here it will be an absorber. So definitely the concentration of an concentration of an atropine, so whatever the concentration of an atropine, so that will react with an BCG, bromocresol green. And as the complex it will be increasing, the concentration complex it will be increasing, absorbance will also increase. So this way you need to make a calibration curve for standard atropine solution. And similarly, further we need to take and blank. For this blank, just remove this part, right? Just remove this part of an atropine. Remaining procedure it will be same, like take 5 ml of an phosphate buffer solution and 5 ml of BCG solution, and extract with 1 plus 2 plus 3 plus 4 ml. So it will become totally an 10 ml. So of that you need to utilize as an blank solution for calculation of an calibration curve. So this it will be blank, and these are the 5 concentrations of an atropine standard solution. Now further, like sample preparation, here we can take any gram. I have taken a 10 gram, so it is not mandatory that you can take a 10 gram. Whatever the reference, I will show that references, some are having a 10 gram, some are saying 100 grams, some are saying 5 grams. So as per convenience, whatever the Soxhlet extraction assembly do you have at your institute, as per you can take, because at the end I will tell you how to calculate for 100 gram. Usually we are calculating for 100 gram. So I have taken 10 gram assembly and with an methanol. So here roughly you can take 100 ml of an methanol. So as per again whatever the plant material you are taking, you can take it roughly, because that will not change the value. So best way to, in case of an Soxhlet extraction, have 1:10. 1:10 means if you are taking 1 gram, at least have an 10 ml of an solvent for the purpose of an extraction. So continue it for an 24 hours till the siphon tube it becomes colorless. So it generally it becomes colorless after 15-16 hours. So you can continue it for 24 hours. So when this siphon tube it becomes an colorless, at that moment also you can stop, because not everything, this is a general procedure for an Soxhlet extraction. In case of some compounds which to be extracted, they are extracted in minimum time, but as soon as 100 cycles are completed, or the siphon tubes when it becomes an colorless, at that time you can remove the extract. Now further, the extract was dried by a rotatory evaporator under a vacuum. So this instrument is called rotatory evaporator, and under a vacuum. Why under a vacuum? Because the heat, whatever the heat it is been required for an extraction of an methanol, so this heat will not disturb, because the boiling point of an methanol it will be reduced, because we are utilizing a vacuum over here. And if you are not having the instrument at your institute, you can use a conventional method, like keep in a petri plate and dry it at a room temperature. So at room temperature also methanol will be that methanol it will get evaporated, and make sure that compound is totally dry, but don't heat it by some any other means like direct heating, because the product may destroy, or the alkaloids which are present in the product may destroy. So better way, take in a petri plate and allow it to stand for 2-3 days or 1 day, unless and methanol it has been completely evaporated. Now next thing is that sample preparation. Once extract it has been prepared, so extract you need to dissolve in 2 normal HCl and then filtered. So how much you need to dissolve? So I will come to that point, how much you need to dissolve, and then filtered. If required, then filter. If there is nothing for infiltration, if there is no residue which is remaining, if residue it is remaining, then you can filter it. If there is no residue, completely it is soluble, then you can filter it. In one of a paper, research paper, I have found that we need to add the 2 normal HCl up to pH 2, or in some research paper it has been said that till dissolved. Extract, when we add extract to 2 normal HCl, add 2 normal HCl to the point. So nowhere the procedure it has been given how much ml of an HCl it is to be added, 2 normal HCl. So dissolve till it completely dissolves, whatever the extract it completely dissolves, or if so, you can use this point also, that is up to pH 2, or better way, most of the people they are saying till it dissolves. So till the extract it is completely dissolved, so add 2 normal HCl. If suppose by adding an HCl still it is not dissolving, then you need to filter, and the filtrate we need to utilize. And so the reason behind it is that I will let you explain the reason also. See here, alkaloids are basic in nature. Alkaloids are say the extract contains an alkaloid. Extract it contains an alkaloids. So I will write just A, alkaloid. And this alkaloid, when we are treating with an HCl, it will form a salt. It will form a salt. So salt, it will be soluble right? And remaining residue, whatever the organic residue it has been remaining of an plant material, so that will after by filtration that will get separated. And from this again we need to understand, from this we have to only take 1 ml. See, some of the procedures given in the paper or book, so they have not mentioned how much to take, but I will tell you why we need to take an 1 ml. So take 1 ml of a solution from this, and then add to a separatory funnel and wash with 10 ml chloroform. So 10 ml chloroform 3 times. Right? So totally it will become an 30 ml. So for 10 ml chloroform we need to wash, means 30 ml we need to wash. And why? Because this salt, whatever it is being formed of an alkaloid plus HCl, this salt it is not soluble in chloroform, not soluble as chloroform. It is an organic solvent, so this salt not soluble in chloroform layer. So whatever the organic material it is having, another extract, plant extract like organic material, so this organic material it will get dissolved in the chloroform, which will not interfere with an absorbance during recording. So that is why we need to extract in the chloroform 3 times. So don't worry about that whether the salt which has been formed that will be not soluble in the chloroform. So we can add HCl in little bit high concentration also. As soon as the salt it has been formed, we again has to neutralize that salt. So again what we need to do, like it is a basic reaction. So this basic reaction means what? When we add an NaOH to it, so this salt where we need to add an NaOH to it. So for what? Not for a chloroform layer. We are just washing with chloroform, right? So chloroform layer we does not require it. We require a solution, whatever the 1 ml solution we have taken. So we require that solution only, and the salt which is formed now in the solution, when we add NaOH to it for neutralizing it. So after neutralizing, so adjust the value till the pH becomes neutral. So again there is no volume which has been given, so you need to add till the pH paper it becomes a neutral. And once the NaOH it has been added to it, again see the salt of an HCl and NaOH, so it will become an NaCl plus H2O, and whatever the alkaloid which was present, so this alkaloid it will again separate. So whatever the salt which was formed with an acid, so that alkaloid again it will separate, because NaOH it is a strong base which will separate again, which will react with an HCl, and this HCl it will form an NaCl plus water, and alkaloid again it will be separated. Now this alkaloid, once this alkaloid it has been freed, so we need to add an 5 ml BCG, that is bromocresol green, and again 5 ml of phosphate buffer solution. See here why we are taking 1 ml of a solution only. See, suppose I have added almost 10 ml of an HCl, and the extract it was almost 1 gram of an extract that I got. So total roughly it becomes an 11 ml. So when we are taking an 11 ml directly, as such in the some of the procedures they have given directly, they have not mentioned of an 1 ml, but most of the procedures they have shown 1 ml. See, if we are taking directly an 1 ml, at the time of this reaction with BCG and phosphate buffer, when this bromocresol it will react with this extract, 11 ml of an extract, so this extract it will be very high, right? So this extract it will be very high. So purposely we have taken 1 ml of an extract, and we are reacting with 1 ml of an BCG solution. Later on we can calculate it, if we are having a total of an 11 ml, I will show you how to calculate by using a dilution factor total content. So just take 1 ml, and after that add 5 ml of an BCG and 5 ml of an phosphate buffer. Now it will form a complex, that extract it will form a complex with the BCG, and then shake the mixture and extract the yellow color complex. Again the yellow color complex it will be formed, and again repeat the procedure same, that 1 plus 2 plus 3, and plus 4, so it becomes 10 ml. And this 10 ml chloroform, by vigorous shaking in separating funnel, firstly we need to add 1 ml of an chloroform, then 2 ml, then 3 ml, then 4 ml, and then collect the extract in 10 ml of an volumetric flask. If required to dilute, you can dilute with chloroform. It will not interfere with an absorbance, so you can dilute up to 10 ml. So remember that again we need to add 1 plus 2 plus 3 and plus 4. So this is how you can prepare a sample. So don't confuse with anything over this point. If you are having any confusion, you can comment me. After a lot of discussion with an experts and after a lot of referencing, I have came to this procedure. See, the books, whichever they are been referred, given by an PCI reference book, that book does not contain and everything. So I have given everything in this procedure, though there are no loopholes for an understanding. So everything I have understood, I have made you understand. After that, we will see now an calculation part. Now you need to prepare an observation table in such a way. So these are the concentrations that we have taken. So how it becomes 40 ppm, 60, 80, 100 and 120. So I will let you know. And you have to record an absorbance on spectrophotometer, UV spectrophotometer. And 6, that is unknown. Unknown means that is sample for which we are determining the concentration. So we will see this calculation in Excel. Just I will let you know how this become an 40 ppm. See, from 100 ppm solution, so we have prepared a stock solution of an 100. So this was the first solution, and from that we have pipetted out 0.4 ml. And see this 4 ml. So we are talking about an 40 ppm concentration. So 4 ml we have pipetted out from it. So 4 ml we have pipetted, and we have dissolved in like so we dissolved in 5 ml of an BCG, right? CG plus 5 ml phosphate buffer, and I will just write B for buffer. And then we have extracted in 10 ml of an chloroform. So 10 ml of an 10 ml of an chloroform that we have extracted. See now how it becomes an 10 ppm. At the last volume it is 10 ml, right? So we are extracting from this 10 ml, and from this 10 ml whatever the complex which is being formed, it is to be noted that this 0.4 ml atropine, it forms a complex with BCG, and whatever the complex it will form, so atropine here it was 40.4 ml, and we have dissolved in the at the last in the 10 ml of an chloroform. So to know how the concentration it becomes 40 ppm, so 0.4 ml, 0.4 ml, and we have dissolved in 10 ml of an chloroform. At the last we have extracted it in the 10 ml of chloroform, and the concentration it was 100 ppm. So from 100 ppm we have pipetted out this solution. So now the concentration it becomes like 40 ppm, 40 ppm. So this is how you can make further calculations also. Like for 60 ppm it will be 0.6, and similar way you can prepare the calculations of this concentration for 60, 80, 100 and 120. Hope you understood this part, and now we will see the further calculation in Excel, how to calculate that line equation. Now we are in Excel. See here we are having concentration and absorbance. So in Excel what you do, just select the cells having concentration and absorbance. Now go in insert option, and there you will find charts. So in the charts you come on the scatter. So I will click on the scatter and just click on any point, and then click on the left cursor and add a trend line. You will have this option, add a trend line. So I will select a linear trend line. See this Excel, it is very recent in old version Excel, so this it might be a little bit different. And once you add a linear, then you set display equation on chart. So click on that display equation on chart. Remaining values like display on R square values, that is not needed for us. So just I will take this point, that is display equation on chart. So I will close it. So I will just zoom in it so you can see it better. Now see on the y axis, you can see it is an absorbance, and on the x axis it is having an concentrations. So these are the concentration, that is 40, 60, 80, 100 and 120 ppm. And this equation, it is a line equation, or it is also called y is equal to mx plus c. So this equation, what it is actually, I will let know it. So here the equation is that like y is equal to mx plus c. So c, it is an intercept. C, it is an intercept on an y-axis. So that is c, intercept. And after that, m, it is slope. So slope of x and y. And x it means a concentration, and y it means an absorbance. So absorbance we will know, right? We will know the absorbance. So I will write some here demo absorbance also for your purpose, and after that we will find out the concentration. So just a minute. So I have rearranged this equation for a purpose of an calculation. So here y minus c, because when c it comes on the other side, it will carry a negative sign as it is plus over here. So y minus c, and m it is multiplied, so it will become divide, and remaining the part, it will remain only an x. So x, it means that we need to find out an concentration. So now for calculation in Excel, I have written over here x, and I will find out the concentration. So I have written one of a demo reading, that is 0.95. I will write it, I will solve it. Now press equal to, see the value of y, so that is absorbance. So it is, firstly put a bracket, so it is 0.095, and minus, so minus c, so c here it is intercept, right? So that is 0.0032, right? 0.032, bracket completed, divided by, so divided by m, so m, that is slope, so slope it is 0.003. So from this equation you can rearrange this value and then press the enter. So you got, I think 10 it was missing. Okay. So you got the concentration, that was 306 microgram per ml, or ppm. Now further we need to see the procedure, how much we have diluted it, and as per how much that 10 gram it contains. As in Soxhlet extraction we have taken 10 gram, so how much the required, how much total estimation it will give. So the advantage of this equation is that you can see the absorbance value, the range it is only up to and 0.035, but the absorbance value here it was higher. Though it is higher, but with the help of this equation we can calculate it. So that is one of an advantage. By just an extrapolation we cannot do the calculation when the absorbance it is out of a range. So that is why we have taken also an 1 ml. If you remember that in procedure I have told you that we have taken 1 ml as the concentration, whatever we have taken, that should react with an BCG solution completely. So further what need to do, what results you need to write, I will show you further calculations also. For total estimation, now you remember that, see the unknown concentration that we got. So unknown concentration, I will write here unknown concentration as per the line equation we got. So that was 306 ppm or microgram per ml. So it was ppm or micro, or I will write or microgram per ml. So this is what we got. And now if you remember that when we have done an extraction, so extraction I consider that it was 1 gram, and in that 2 normal HCl that I added, it was almost 10 ml. So it was these values may be changed in your experiment. So I'm having just a demonstration that you need to understand it. So roughly it will be an suppose 11 ml, almost I have considered it, and from this we have taken only 1 ml for further extraction. And this extraction means we have reacted with BCG plus buffer, right, phosphate buffer that we have done, and we have again extracted in chloroform, and then we checked the absorbance of it, right? So now here we have taken only 1 ml. Now we have to go back again. If 1 ml it contains 306 ppm, then 11 ml it should contain how much, right? So 11 ml should contain how much? So for that purpose, see, 1 ml it gives 306 ppm value. Then 11 ml what it should give. So calculate this x. So the value of x, it will be almost 366, right? 366. Now it is it was for earlier it was microgram per ml, right? Now we have calculated it is 11 per ml, right? So it is a total value now, right? So it is total value that we got it from total alkaloidal content. Now we need to convert it to an milligram. So for conversion into an milligram, divide it by 1000, right? So once you divide it by 1000, it becomes 3366 milligram, right? So it becomes 336 milligram. Here it is microgram. So I have divided it by 1000 and I got the value, that is 336 milligram. Now in case of a result, what you need to write, see, in case of a result, the total alkaloid contained in 10 gram, because we have started with an assembly of 10 gram, was found to be so that is 3.366 milligram. So this is how you have to write the result at the end. If you are having any problems, you can write in the comment box at any moment. If I am wrong, you can also suggest me. So thank you for